Have you ever really stopped to think about how your teeth are held in your head? You'd think they'd be, I don't know, welded directly to your jawbone for strength, right? But they're not. Nope. Instead, they're held in place by this incredible, kind of counterintuitive suspension system. Today, we're going to dive into the amazing engineering that keeps your teeth right where they should be. So, yeah, that's the big question, isn't it? Why on earth aren't our teeth just fused solid to the jawbone? I mean, it seems like that would be the simplest, strongest way to do it, especially for something that has to crush and grind food every single day. But as it turns out, biology had a much better idea. And that's because this little bit of looseness, it isn't a weakness. It's not a design flaw at all. It's actually a highly evolved, incredibly sophisticated system that is just better than simple fusion in every way. And we're about to find out exactly why.
Okay, so to really get this, we need to uncover the tooth's big secret, this unique joint that holds the whole thing together.
It's called a gomphosis. The name actually comes from the Greek word for bolt, which is kind of cool. And it's this special kind of peg and socket joint. Now, what makes this joint so wild is that it's the only one like it in your entire body. It's the only place where something that isn't bone, your tooth, connects directly to bone. The whole design is built around this one fundamental idea, a hard, soft, hard architecture. So you've got the hard bone of your jaw, the hard root of your tooth, and they are very deliberately separated by a critical layer of soft tissue. That soft layer, well, that's the secret sauce. That's the key to everything. All right, let's start breaking down the pieces of this incredible shock-absorbing system. So you've got three main players. First, there's the alveolar bone. That's the special part of your jaw that creates the actual socket for the tooth. Then, coating the root of the tooth, you have a bone-like layer called cementum. And smack dab in between those two hard layers is this super important gap, the periodontal space. So what's in that space? This is the hero of our story, the periodontal ligament, or PDL for short. It's this thin but incredibly strong layer of living, soft tissue that fills that gap completely. Think of it like a high-tech hammock or sling that holds the tooth perfectly in place. And get this, the width of this all-important ligament is only about 0.15 to 0.38 millimeters. That's what, about the thickness of a few sheets of paper? It's just a stunning example of precision biological engineering.
But the PDL is so much more than just a biological bungee cord. It's a dynamic living tissue that has some truly unbelievable abilities that make it absolutely essential.
You could say it basically has three superpowers. It's a really sophisticated shock absorber, a super sensitive sensory organ, and a dynamic, constantly working remodeling engine. So let's check out each one. First up, the shock absorber. The PDL is about 70% water. And since you can't really compress water, it acts like a perfect hydronic cushion. So when you bite down hard, this system does something brilliant. It converts that crushing force into gentle tension, a pulling force on the jawbone, which is something bone is incredibly good at handling. Okay, its second job is being a sensory organ, and this quote just nails it. The reason you have such amazing control over your bite, the reason you can go from cracking a nut to gently holding a potato chip, is because the PDL is packed with these tiny nerve endings called mechanoreceptors. They give constant, real-time feedback to your brain about exactly how much pressure you're using. And this right here, this is the third role, and it's maybe the coolest of all. The PDL is the remodeling engine. This is literally how braces work. When that wire puts pressure on a tooth, cells on the side being squished, called osteoclasts, actually dissolve a little bit of bone to make way. Meanwhile, on the other side, the tension side, cells called osteoblasts build new bone. The whole tooth socket literally travels through your jawbone. It's incredible, and it would be totally impossible if your tooth was just fused in place. This table does a great job of summing it all up. You can see how all the different parts work together. You've got these strong collagen fibers for tensile strength, the watery ground substance acting as that hydraulic shock absorber we talked about, all the different cells that do that remodeling for things like braces, and of course, the network of nerves providing that all-important sensory feedback. It's like a whole little ecosystem in that tiny space. Now, if you want the absolute final smoking gun proof of how important the PDL is, all you have to do is look at what happens when the system fails. The condition is known as dental ankylosis, and it's exactly what it sounds like. A pathological fusion where the tooth root sticks directly to the jawbone. It creates the exact rigid, fused scenario our biology works so elegantly to prevent. And wow, the difference is just night and day. A healthy tooth with its PDL has a tiny bit of give, it absorbs shock, and it adapts as you grow. But an ankylosed tooth, it's completely stuck. It makes a sharp, high-pitched clink sound when a dentist taps on it, not a dull thud. And because it can't move, it often looks like it's sinking as a person's jaw grows around it. Every single symptom is a direct result of one of the PDL's jobs being lost. So why did we even evolve this complicated setup in the first place? Well, the answer takes us millions of years back in time, and it reveals that this system is nothing short of an evolutionary masterpiece. You know, our distant reptilian ancestors, they actually had fused teeth. And for them, it was fine. They were mostly just grasping and swallowing things whole. But then, mammals came along, and we evolved these powerful jaws for really chewing our food. That old rigid system just couldn't handle the new forces. The evolution of the periodontal ligament was the absolute game-changing adaptation that made the modern mammalian bite possible. So here's the bottom line. The PDL was the biological key that unlocked advanced chewing. And because we could chew so well, we could eat all kinds of new foods. That was a huge factor in why mammals were able to diversify and succeed all over the planet. I think this quote from the source material just sums up the whole story perfectly. It calls the PDL a dynamic, living interface that is strong yet resilient, stable yet adaptable, and robust yet sensitive, a perfect biological solution to a complex engineering challenge. Couldn't have said it better myself. So, in the end, our teeth aren't fused to the bone because a living, adaptable, intelligent suspension system is just a flat-out better design. And it really makes you wonder, doesn't it? What other so-called flaws in our bodies are actually elegant, hard-won solutions to some really complex problems?